In this video, we'll see the benefits brought by simulation during the design phase. Let's talk about the structural simulation. So for this case, I would like to focus on this bracket. This is a commercial part coming from a standard library. And first of all, I would like to double check if this bracket behaves and support correctly the loads where it's designed for. So this bracket, I have two brackets, one of each side of my device, and they're in charge to hang the table where all the equipment are installed. So the mass of that is more or less 10 kilos, or apply 5 kilos for each bracket. And as you can see there, I have to select the different locations where the table is fixed, and I apply remote mass, because mass is not exactly at this position. And on the other side, I have to select where I have to fix that. The HUD, everything is around the mouse, so I just have to click somewhere, and all the boundary condition, everything is around the mouse. So I define the plastic material for this part is an ABS and run the simulation. And a couple of seconds after, I have an answer. Okay, you see the graphic display there showing the displacement. So of course there, it's not the exact displacement. The view is amplified to visualize something. I can also show the constraints, the von Mises constraints, but much more value can be post-treated. Okay. What is interesting there to notice is the value of the safety factor. So what the safety factor means, the value there is 1.3. That means I can apply 30% more of the actual mass. Okay. So the original mass of my model was about 70 grams, so I expect to have more or less exactly the same thing, but much stronger, of course. So I'm gonna to use another material, okay, and I will also reduce the number of screws and fixation. So that's why I reduce the number of fixation on both sides, okay, and yeah. That's all. What I'm doing right now is just, I would say, a classic simplification, like you know, in SpaceClam. So I select some faces and just use my fill command. And now I have to define the material. So use the library, type the first letters, and in this case, I'm gonna choose aluminum. Okay, that's what I need for this application. Okay, so for my topology optimization, you see by default all the boundary condition have preserved areas. So that's the pink rings we can see on the screen. And there I'm gonna to do something pretty drastic, because I'm asking to remove 80% of the material. Okay, that's a lot, of course. So just to be sure to track the convergence of my model, I would like to track the mass, and I can stop when I need. I don't have to wait till the end of the optimization process, okay? And you can see that step after step. So the first nice thing is I can follow in live the different optimization steps. So I perfectly see in which direction my solution goes, okay? If it converges exactly in the way I think or not, okay? So I can stop, change the setting and stuff like that. And you see that after, yeah, it's about 10 iterations, I'm more or less where I need. So I still need to wait and to have a flat curve. And okay, it gives the feeling to be flatter. Okay, that's fine. If I look at the graph there on the side, yeah, the mass is about 70 grams. It's more or less like this. We will check at the end, but I guess I have the correct mass. So based on that, I could maybe wait a couple of iterations and stop it. Okay, and again, that's really interesting because it's fast, it's super fast, and all of the stuff you see there, it's ran on my computer in live. Okay, so it's okay. I can stop the simulation there and look at the result. Okay, so if I look around, okay, of course a lot of material have been removed. That seems clear. Okay, and then I can change and I can show the displacement at the case here, or I can view another value to post-treat, with the constraints or whatever. But what is interesting is based on the result there, I can generate a new model. So I generate a new STL file, so based on the model optimized, and then from this model I create a new validation study. Okay, so automatically Discovery create a new study, reapply the boundary condition, everything on the result. and then I ran new structural simulation on this new part, and you can see the result there. And the first thing I can see, I can double check, is the safety factor. So the safety factor when the model will be converged, so I still have to wait a couple of seconds down. You see the safety factor, it's 10. Okay, that's mean I can apply 10 times my existing load. So I could still optimize yet the model. Okay, I could increase again that. And the displacement, it's much lower. I had something like 0.7 millimeters, and now it's about of microns. So that's excellent for the accuracy I need for my printing machine. So then, what I did there, I switched back to my original simulation and I make something smoother. It's much better, as you can see. But I can go one step after. I can recreate a solid based on this STL. So the process is automatically done, as you can see there. It's super nice, and I can extract that in the software, so whatever. Or I could simply go back into SpaceClaim to reintroduce that in my existing design. Okay, so this is what I do right now. So the most important there to retain one more time is I'm a design engineer, and my job every day is to design new parts, to imagine new concepts. I'm not a simulation expert. I just use the benefit of the simulation and because of the discovery and thanks to provide me a so fast feedback in the simulation to improve my design to make much better product.